Okay. So preliminary hazard analysis, this is more of a simple step. It's simple but systematic, usually an inductive method of analysis whose the objective is to identify the hazards and hazardous situations and events that can cause harm for a given activity, facility, or system. So this is the objective of a PHA. A PHA is a simple method compared to other methods. Okay. Generally, all those methods can be divided into two parts or three. One of them is called preliminary, which is preliminary means simple, like PHA, preliminary hazard analysis, while the other ones are called detailed hazard analysis. Okay. So usually people carry out a preliminary hazard analysis first before going further to carry out a detailed hazard analysis. Now, PHA is preliminary. As I said, preliminary means initial step, which means it's in the beginning that you carry out this. Now, it's used many times in many industries, many applications like that. Now, PHA is used for a variety of used by safety professionals to identify hazards. Okay, so assess necessary control measures and how risk levels to be allow for risk levels to be prioritized for further risk assessment and management. So this is the essence of PHE. One of them is first of all to identify the hazard. The second one is to calculate the risk levels, which means what? Analyze the risk. Okay. And lastly is what? Risk evaluation, which means what? How to prioritize the risk and what further action needs to be taken. Now, its primary purpose is to identify and describe significant hazards that might arise from defects and unsafe conditions in the design and operation of a or subsystem. Okay. So basically, you're trying to identify significant hazard. It doesn't really. Bottom line is that whatever hazard, whether it's coming from a defect or it's an unsafe condition or from the system, the management, or from any other category, this is the essence of risk assessment. So here, the primary purpose is to identify and describe significant hazards that might arise from defects. Okay, it is especially useful in providing an analysis of current state of risk levels, as I usually explain to you, determine what's the current level of the risk, and the risk reduction levels of proposed risk treatment. So this is one of the main advantages of preliminary hazard analysis. It allows you to identify or determine the current level of the risk, also the future level of the risk once you calculate what the risk levels and the effectiveness on controls, and also allows you to analyze the effectiveness of proposed risk treatment methods. Okay. Now, so like I said, PHA will lead to more refined analysis, which means that PHA is considered usually as the first step, like that's why I call it preliminary. Preliminary means something that you start with, something that is in the beginning. Okay. So it's more like a primary risk analysis method, which will lead to more detailed risk analysis method like FMEA, failure mode and effect analysis, or you can call it FEMICA. Okay. FEMICA means what? Failure, mode, effect, and criticality analysis. Okay. So you could call it FEMICA. All right. So we have this one here. Also, we have 4-tree analysis. Okay. And there could be other forms of analysis. Okay. So PHA could be the first step, and then after that, we can follow PHA with some of these detailed forms of analysis. Now, these methods are commonly used to further identify, evaluate, and avoid hazards in more complex or safety-sensitive designs. Okay, so use all these other methods in more complex, which means could be more complex systems or designs of equipment or processes, things like that. So PHA should be updated as necessary. You need to go back to PHA, review it, update it with new hazard risk analysis, and with new controls. PHA also stands for process hazard analysis, so we should not get it confused. There's PHA, which refers to preliminary hazard analysis. There's also another PHA called process hazard analysis. Okay, this one applies in the process safety management of highly hazardous chemicals and environmental protection risk management program for chemical accidental release and accidental release prevention regulations. So this PSHA here, okay, you can say PSHA or PHA. This one refers to process safety or process hazard analysis, okay. Now, what are the steps in carrying out PHA? PHA is similar to other risk analysis. We follow some particular steps, including one, establishing the context. What is the context of the risk assessment? Okay, context and what's the objective? Okay, what's the objective? The length of time is it take, the number of people that we take. What are the things that you want to consider? Your scope, the places that you want to carry out the risk assessment, and places that are outside your scope, where you are not going to carry out any risk assessment. So all this will be defined in the context. What kind of risk matrix are you going to use? All this will be determined in the context of the risk assessment. The next one is what? Establish PHA team. Okay, this the preliminary hazard analysis team. Okay, so like we discussed previously about team formation. All right, you have to ensure that you have an expert in different areas to form up your team. Next is we have the list of hazards. This is hazard identification. Okay, this one is called hazard identification or hazard or you can call it risky as well. Hazard or risky, where you develop a list of hazards or identify all possible potential hazards. Okay, you develop your PHA worksheet, which is a table. PHA worksheet, you're going to see an example soon. Okay, this is a table where you have all your hazards in one corner. You have the controls in one corner, right? Yeah, so something like that. Okay, we shall see soon. Then you estimate the current state severity, current state risk level, current state risk likelihood level, and then current state risk level. So basically, what is the current state means now, currently? How is the situation now in the site? And this is also after implementing the existing structural controls. Okay. Next is select proposed risk control. Okay. What do you want to do as a recommendation for the risks that have been identified? And estimate future state severity, likelihood, and risk levels. Next thing is to move to the future state, where you determine the severity, the likelihood, and the risk levels. Okay, the level of the risk. So this is an example here, as you can see, that you have biodiesel production. This ID number 3, number 1, number 2. Now, what is the hazard? Talks about human error, explosion from this, thermal expansion, corrosion. All these are hazards, okay? All these are hazards. Then exposure description describes also how exposed it is, why people are exposed, existing controls. So based on these existing controls, what do you consider severity? Severity is 5. Severity is 4. Severity is 4. Well, based on this severity multiplied by the likelihood, is going to give you what? The risk level. Okay. The risk level for the highest one is 15. You can see it's in the red region because it is between 15 and 20, which is classified as very high, depending on the risk matrix that you are using. Okay. Followed by 12. Followed by 8. You can see that 12 is in orange and 8 is in green. So we want to see how possible to convert everything to green or at least maintain one red. So we got some controls, okay? You can put them in different categories. Engineering control, warning, we have admin. So basically it has various kinds of control. So under each of them, they can put some controls on what to do. Like this one, field alarm, This one talks about mechanical integrity program. Okay, so basically it's like subtopics or things that need to be done to fulfill this control method. So based on that, you can see this severity is coming down or likelihood is coming down. This one's severity remains the same, 5. But likelihood has dropped from 15 to 1. 15 times 1 is what? Is 5. Similarly, you have engineering, one in admin and PPA. Okay, and you have here, which is the current state of the risk. Now that is 4. The likelihood is brought down to 1, okay, because the likelihood is 3. Bring it down to 1. You have it was with likelihood, and 4 by 1 is 4. Okay. The last one is what also you can see you have engineering controls, you have admin controls, and this helps to bring down the likelihood to 2. Sorry, brings down the likelihood to 1. Okay, from 2 to 1. And the new risk in this case is 4, which is in the green region. So you can see this is how a PHA looks like. Okay, filling all these tables and having the color codes to show which one is red and which one is green. Okay. As for process hazard analysis, like I said to you previously, that's with the process industries, is organized and systematic assessment of potential hazard associated with industrial process. Now, PHA, which process analysis, is directed towards analyzing potential causes and consequences of fires, explosion, releases of toxic or flammable chemicals, focuses on equipment and instrumentation, utilities, human actions, and the external factors that may impact the process. Now, in many cases, an additional benefit of conducting such analysis is a more thorough understanding of the industrial process, okay, leading to leading to opportunities for improving process efficiency and cost reduction. Okay, so process safety can help you to achieve all this. Whereby someone that does the process hazard analysis is able to understand in depth what the process is about and what are the faults it may have and things like that. So lastly, we come to OSHA, some of the regulations by OSHA and by EPA. How is the OSHA 30 safe now? CFR, process safety management is of highly hazardous chemicals standard established in 1992. This requires process hazard analysis for regulated industrial processes where there's more than 10,000 pounds. Okay, when you have more than 10,000 pounds or more of a hazardous chemical, okay, so you have to carry out process safety purpose of protecting the employees working in and around the processes, around such processes. Next one is EPA, the Environmental Protection Agency, which states that chemical accident prevention provisions, risk management plan rule based in 1994 is a result of the Clean Air Act, okay, of the Clean Air Act amendments of 1990. Now, the safety management requirements for process hazard analysis in regulated facilities for the purpose of protecting the public environment from undesired consequences of explosion or releases. So basically, it's that there are two approaches that people have looked at in terms of, and these are mandatory approaches for process safety or hazards in the process industry. The first one is what based on OSHA, where you have to carry out a PSM, that's process safety management, for any site or any industrial facility or processes that has more than 10,000 pounds of hazardous material. Next one is EPA. EPA also has its own regulation regarding process safety management, and then it believes that purpose of protecting public and the environment from undesired consequences of explosions or releases. That is the job of EPA, especially this part that relates to process safety management. That brings us to the end of the first part of risk analysis tools. Okay. So in this case, we're going to end the recording.